If you have questions, feel free to email me, okay? So you study the homework, you can click the view detail and see the full solution of your homework, right, everybody? And so you can save as a PDF, and then you can study the homework. So you can see all the homework solutions. Just click the view detail button after you submit your homework. And yeah, study the quiz. We have the quiz solutions and the quiz mistakes posted on the website, right? And also the practice exams. So you first finish your practice exam with pencil, and then you can use red pen or any other color pen to make corrections, and also grade it. So estimate the scores, and then add them out to get the total scores. Is that clear, everybody? If for some problem you didn't get like good scores, then find some similar problem to practice. Okay, everybody? That's the practice exam. And now let's look at the quiz 3 solution. So quiz 3, we want to write the quadratic function. So this is the general form. Ax squared plus bx plus c. This is the general form. You want to write it in the standard form. What's the standard form? A times x minus h squared plus k. Right, everybody? This is the standard form. Sometimes we'll call it vertex form. Okay, so standard form, vertex form, that means we have y equals to a, parentheses, x minus h squared plus k. And how do you find your h? Well, some of you didn't show your work, so in the exam, please make sure you show your work. Okay, so your h equals minus b over 2a. And in this case, your a is -2, your b is the coefficient of x, which is 16, and your c is -31, right? So minus b over 2a, you plug in the numbers, you get 4. Okay, h is 4. But in the standard form, you are putting x minus h. That's why you have x minus 4. Is that clear, everybody? And how do we find the k? We plug in f of h. But h is 4, so you plug the 4 into our quadratic, like this formula, right? Replace x by 4. So -2 times 4 squared is 16. 2 times 31. And we know that 64 is like 2 copies of 32. So that's why 64 minus 32 is still 32. And then minus 31 is 1. Okay, so we get h and k. That's the vertex. Okay, so some of you didn't specify. Okay, what's this? This is a vertex. So write it down. Vertex is this point. And then axis of symmetry is a vertical line. X equals 4. Okay? And the standard form, this is the standard form. And because the A is negative, so the parabola opens down. Okay, everybody? So for the important point, like the vertex, please label them. Okay. And for this problem, because I didn't ask you to find the x-intercept, so you do not have to find the intercept. But in the exam, if I ask you to find the x-intercept, what do? We set y equal to 0. So set this equal to 0, and then you can use quadratic formula to find the two roots. Right, everybody? So that is problem number 1. Okay, problem number 2. We want to graph this polynomial functions. And then because it's already factored, so the first thing we do is we set each factor equal to 0. And remember your x-intercepts, they are points, okay? Points is an order pair, so parentheses, the x-coordinates, comma, the y-coordinates, parentheses. So that's why, okay, x-intercept are 2, 0. perfect scores on your homework. Please work on your homework. Okay. All right. And okay, great. So that's the quiz. And let's look at the mistakes. So quiz 3 mistakes. Let's see, quiz 3 mistakes. Where is it? Okay. So here, standard form. This is the general form, ax squared plus bx plus c. This is general form. Standard form means a times x minus h squared plus k. This is the standard form, so that's why this is wrong. Okay? By the way, on the exams, no graphing calculator, only scientific calculator. Okay, everybody? So make sure you bring a scientific calculator. Graphing calculator is not allowed. That's why we learn in class how to graph the function, right? Starting with the parent function and then do the transformations. Okay, and then here, so this is the 1/6 right here. Okay, so miss that. And forget to write down the leading coefficients. Okay, so you need to show all your work to get the scores, credits. Okay. And then here, because your leading coefficient -2 is negative, so parabola opens down. And then here, see, coefficient is not just that number. You also need to multiply the coefficient of x in each vector. Is that clear, everybody? Yes? Okay. So many of you have this mistake. That's why lose 0.5. Okay. And x-intercept, y-intercept, they are points, not number. Okay. So, and here, be careful, square, quadratic function, degree 2. And your h is 4. So this is 4, not -4. When you put it in the standard form, you put -4, but your h is actually 4. That's why 40 is this point. A is negative, open down. Okay. And again, leading coefficient is not correct. And that's why this is negative, so you start with the right lower corner. Okay. And then here, leading coefficient is not correct, even though your picture is correct. But when I grade your work, I still need to look at, okay, is all the points correct? Okay, so leading coefficient, write it down in the exam. And yeah, forget to write down the leading coefficient, forget to write down the leading coefficient, and forget to write it down. And what is the standard form? So when you read the problem really carefully, make sure you answer all the parts. Okay, standard form. What is the standard form? Okay. And here, yes, your y-intercept, 42. So label the important point means the x-intercept and the y-intercept. And they are points, they are not numbers. Be careful. And yeah, leading coefficient is negative, but please write down what it is. Okay, so I want to make sure you know the requirements. Write down what's the leading coefficient. You do not need to calculate this number, what it is, but at least write down the expressions. I'm not asking you to figure out what's this fraction, okay? But write it down. Is that clear, everybody? Mm-hmm. Yes. Okay, so show your work. And then, when you submit your quiz, make sure you are able to read all the numbers. Because sometimes it's hard for me to read it, right? Yeah, so make sure when you take the picture, you're under the good light, so you can read it, right? And what's the leading coefficient? And see, this is 1/6. And so don't cross it. Just touch it and then bounce. Okay? Because if you go down and then cross, it looks like there are two x-intercepts here. So draw a picture carefully. And then here, what's the axis? So this is a vertex, and what is the axis of symmetry? Yeah, write it down. Oh, okay. The student is using the method completing the square. So in your exam, if you forget the method of completing the square, you can use the formula. I would say using the formula is easier, like h equals minus b over 2a and k equals f of h. Is that okay, everybody? Mm-hmm. And then here, okay. So because we're working with the x, when you mean multiply, I try not to use the cross because sometimes your cross look like x, right? So try not to use cross. You can use a dot, okay, to indicate multiplication. So this is the y-intercept. Y-intercept is a point, and you still need to find the x-intercepts and then draw the picture. Okay, so I don't remember who made this mistake, but don't forget to look at the solution. And if you have questions, come to see me. Okay, so yeah, misleading coefficients. Here, the standard form is not correct. So yeah, and miss the second problem. And then this one, acid of symmetry. We have an answer, x equals to 4 is the acid of symmetry. And this is not the standard form. So standard form, again, a times x minus h squared plus k. Yes. All right. And then here, your x-intercept and y-intercept are points. And so you plot the points. They are not line. That's why, see, if you don't put the point x equals to 2, it's like a line. But x-intercept and y-intercept, they are not line. So you plot the points and then find the leading coefficients and then draw the graph. Either cross it or bounce off. It depends on the multiplicity, whether it's odd or even, right? Okay, and then this one, yeah, this is standard form, but what's your A? Write down your A. Your A is -2. And your H, what's your H? 4, so put it down. And miss the leading coefficients. Yeah, this is, see, again, bounce off. Don't go under it. Because if you go under it, see, now you have another x-intercept here. We don't want that. We only want the intercept, or we only have 3 intercepts, not 4. So don't go under that. Just bounce right there. Okay, everybody? And then here, so, okay. No graphing calculator in the exam. So that's why I try to show you how we can find the graph without a calculator. Okay? So, and you need to show all your work. So what's the x-intercept, what's the leading coefficients, and how do you get this picture? And also here, vertex is what? It's correct, but how do you get this vertex? So no graphing calculator here. Okay, how do you get your vertex? You must show all your work in order to receive credits. Is that clear, everybody? Okay. Yes. Okay. So show all your work and label. Okay, label the important points. Because you have so many students. How many students in this class? 34, right? You don't expect me to count for all the students, right? So please label the important points. Especially, look at this, 42. Do you want to put 42 bar right here? No, you don't need to. Just put a dot and say that's 42. Okay? So you, and this is 2. This is 1 set. So you don't have to have like a very accurate scale. Okay? Just put the important point and label it. Okay, and then, yeah, misleading coefficients. So here, be careful. This is the y-intercept. This is not the leading coefficient. So the student confused about the y-intercept and the leading coefficient. The y-intercept, you look at the constant term of each factor. The leading coefficient, you look at the coefficient of x in each factor. Do you see the difference? Yeah, y-intercept is the constant term in each factor. Leading coefficient is the coefficient of x in each factor. So they are different. Be careful. Okay. And here, because the multiplicity odd, so cause it multiplicity even bounce off. Okay. And yeah, that's why I'm thinking about, did you use a graphing calculator? Because graphing calculator is like -10 to 10, and it shows you the graph. So in the exam, no graphing calculator. You have to show all your work in order to receive credits. Okay. And yeah, that's why if you use your graphing calculator and our graph is big, okay? So our graph is usually outside that range, then you might not be able to see it from the graphing calculator. And some of our in-class examples, the y-intercept is like what 3 million something. Remember that? That crazy problem? Yes. So you cannot use your graphing calculator. It's so big, you cannot quite see it. Okay, and let's see here. Square. Yes, small mistake. And here, y-intercept, we plug in x is 0. Okay, so the student plug in the x-intercept in each factor. No. Plug in 0 for the y-intercept. Okay. And the leading coefficient, not enough. You need the other factors. Okay. All right. So yeah, leading coefficient not correct, and that number is wrong. So these two students have the same errors, which is yeah, okay. And then y-intercept are the points, not lines, and miss the leading coefficient. Oh, okay. So be careful. This number is not raised to the power 3, okay? The raised to the power 3 is the 6. The 6 right here. Okay. So yeah, write down what's the leading coefficients. Okay. And here, axis of symmetry, x equals to 4. And they are points, not lines. So be careful. All right. So, do you feel like the exam, the quiz problem, we have some similar in-class examples? Okay, so you can review your in-class notes before taking the quiz. Okay, then you can remember the steps how to solve these kind of problems. And if you miss some class, don't forget we have the recording, right? How do you see the recording? Go to TED Live. Okay, so click our course, go to TED Live, and then click this 3-bar menu, and then you can see the recordings. Okay, I know some of you didn't take notes, but it's very good to take notes because you can write down what you understand and what you don't understand. You put a question mark next to it, and then you can ask me later. And all the notes with answers are also posted on the website. So if you miss something, okay, you can look at the notes posted. Okay. All right. And then here, so here, I don't know how you get the 4 because this number is not 4. So to show your work, how do you get 4? And yeah, x-intercept are points, miss the leading coefficient. Here, miss the square. And here the graph is not correct. Okay, and that's it for the mistake. Any questions about the mistakes? All good? Okay, so take notes in class and ask me questions. Do your homework. Okay, all right. Okay, so today let's continue on session 3.6. Okay, so 3.6, zeros of polynomial functions. Okay, so last time we talked about the remainder theorem. If the polynomial p of x is divided by x minus c, then the remainder is the value p of c. Right? We did example 1, right? We want to find p of -2. Ooh, you see, this is so complicated. If you plug in -2, you need your calculator probably, right? Okay, so, but we can use our remainder theorem to help us because this guy corresponds to the roots -2, okay? So we want to find the remainder when we divide the polynomial by the factor x minus c, so which is x plus 2, okay? And we do sympathetic division. Remember sympathetic division? We write on the roots on the left, and then we write on the coefficients from the highest power to the constant. So 3, 5, -4. Because no x squared, we put 0 here, and then 7, 3. So make sure you have all the power. So if you miss some power, put the 0 there. Is that clear, everybody? Mm-hmm. Okay, so we move this down and then multiply by the roots and then put it the next column. And then we add the numbers in that column and then multiply by the roots and put it into the next column. So we repeat this process until we find the remainder. So p of -2 equals 5. Do you still remember this example? Yes? Okay, let's continue. All right, so we want to find p of -3. So the roots is -3, right? So we put -3 right here. And what are the coefficients? What's the first one? 1, and then -7, and then 0 because no x to the fifth, and then 5, and then 0, 0, 1. Okay, sometimes if you get lost, you can write it down. Okay, this is x7, x6, x5. No, that's why we put 0. Oh, x4, 5, x cubed, x squared. Ooh! Do you see what happened? We miss an x. So, yeah, it's good that we check it. Yeah, oh, right, everybody? So, yes, make sure we check it. Okay. So we start. This is 1. 1 times -3 is -3. Add them, we get -10 times -3 is 30. And we add them, we get 30 times -3, -90. Add them, -85. Okay, what's -85 times -3? 220, what? 255. Thank you. We add them, 255. Okay, and what's that multiplied by -3? -765. Add them, so -765. Multiply by -3. Thank you. So 2,295. Okay, multiply by -3. Negative. Thank you. When we add the 1, oh, we got -6884. So this is the remainder. Is that okay, everybody? So this is the remainder. So p of -3 equals the remainder. So -6884. Okay, so if the problem asks you to use the remainder theorem to find this, you have to do it this way. Is that clear, everybody? You cannot just put -3 into your polynomial function and evaluate. No. I know you get the right answer, but that's not the way that the problem asks you to do it. Is that clear? Mm-hmm. All right. Remainder theorem and then factor theorem. Okay, so factor theorem. A number C is a 0 of P of X if and only if X minus C is a factor of P of X. Okay, do you remember like how we solved the polynomial equations, right? We move all the terms on your left hand side and then you factor it, right? So if we get something like 2x, something wrong with my pen, sorry. Okay, so 2x plus 3, I just make it up. X minus 7 equal to 0, right? And how do you find a 0? Oh, you set each factor equal to 0. And you solve for x. What's x? Yeah, -3/2 and x equals 7. See? You get C is a 0 even only if x minus C is a factor. Right, everybody? See? 7 is a 0 even only if x minus 7 is a factor of the polynomial. Okay, everybody? So that is the factor theorem. So in other words, each 0 corresponds to a factor, and each factor corresponds to a 0. Okay, so example 2. Use the factor theorem to show that x minus 2 is a factor of the polynomial. Okay, so x minus 2 is a factor if and only if 2 is a root of P of x. Do you agree, everybody? Yes, we have the factor theorem. And 2 is a root. That means when we plug in 2, we get 0. Right, everybody? 2 is a root or a 0 of the polynomial. That means if we put this number inside our function, our y value is 0. Right, everybody? So let's verify that. Okay, so let's verify that. Let's check that, okay? Let's check this. So P of 2, okay, equals, now we plug in 2q plus 2 times 2 squared minus 3 times 2 minus 10. What's 2q? 8. And the next one is also 8, right? And minus 2 times 3 is 6 minus 10. Oh, what's that? Yeah, this is 0. See? So we get, this is correct. So that's why 2 is the root of P of x. That's why x minus 2 is a factor. Okay, everybody? Yeah, so x minus 2 is a factor. Okay. All right. And let's look at this. Is x minus 1 a factor of this complicated thing? Okay, let's see. X minus 1 is a factor if and only if what is the root? Yeah, 1, not -1. So 1 is a root. Okay, if and only if what? P of 1 equals 0. Yes. So let's call this P of x. So let's check. P of 1 equals 1 to the 345 plus 3 times 1 to the 172 minus 2 times 1 to the 11 plus 7 times 1 squared minus 9. Yes, everybody? And do you know 1 to the whatever power is 1? Yes. So this is just 1 plus 3 minus 2 plus 7 minus 9. Oh, what is that? 0. How nice. Okay, everybody? So you might think of, okay, to show this is a factor. Can we do division? Can we use this polynomial divided by x minus 2 and we get something to show it is a factor? Yeah, you can do that. But so yeah, so in that problem, let me write it down. Okay. So for this problem, you can do like x cubed plus 2x squared plus minus 3x minus 10. You can use it to divide it by x minus 2. And you want to show you get some polynomial. Okay? So if you get polynomial, that means this this function equals to that polynomial times x minus 2. We can show that. Okay, but this is easy. But imagine here, 345. Do you want to do the division? No way. Okay? Right, everybody? If you do the long division, oh my god, it's 345. That's a big one. It's a very long process. So that's why in this case, use the factor theorem is faster. Okay, everybody? All right. How about this one? So similarly, right, x minus 1 is a factor if and only if p of 1 equal to 0. So what's p of 1? 1 to the 51 is 1 plus 2 times 1, which is 2, minus 4. What's that? Negative 1. Do you see it's not 0? So x minus 1 is not a factor. Okay, so we have example where x minus 1 is a factor. We also have example that x minus 1 is not a factor. So you just plug in 1 into the function to see whether it equals to 0. So far so good, everybody? So no division, no simple division is needed. Okay, very good. Let's keep going. Okay. All right. So next one, we have the rational zeros theorem. So if p of x is a polynomial, it has integer coefficients, then every rational zeros of p of x is of the form p over q, where p is a factor of the constant term a0. So a0 is the constant term, okay? And q is a factor of this is the leading coefficient. Okay. So what does that mean? Okay, a polynomial of degree n, okay, in general, then it should have n roots counting multiplicity. So a polynomial of degree 3 should have 3 roots counting multiplicity, like quadratic equation. We use the quadratic formula, right? It depends on the discriminant. If the discriminant is positive, then we should have 2 real roots, right? If the discriminant is 0, we say 1 real root, but it is a complete square. So it's like 1 real root with multiplicity 2, okay? If the discriminant is negative, we have no real solution. So we have 2 complex solutions, right? That's why we have 2 roots, okay? So degree 2, we have 2 roots, counting multiplicity and counting complex numbers, okay? So the rational theorem tells us that if the roots are rational numbers, then they must be from this list. Okay? The list of the numbers where P over Q, P is a factor of the constant term, and Q is a factor of the leading coefficient. Okay, and caution. The theorems above give us a list of potential rational zeros of a polynomial. If a polynomial has any rational zeros, then they will be on this list. Okay? But not all the numbers on the list need to be the zeros of the polynomial. Okay? Some number might not be the zero. Okay? So be careful. All right, let's look at example. Example 3. Use the rational zero theorem to list all possible rational zeros of the following. Okay, what do we do? Okay, first, let's figure out what's the leading coefficients and the constant term. The leading coefficient is 4, and the constant term is 3, okay? So, we first look at factors of the constant term, which is 3. What are integer factors of 3? So they are plus or minus 1, plus or minus. Is 2 a factor? No. Then it must be 3. Is that okay, everybody? So factors of 3. So 1 times 3, that's 1 can be plus or minus, 3 can be plus or minus. So these are integer factors of the constant term. Okay, second step. What are the factors of the leading coefficients? So you always start with plus or minus 1. And then what is the next number? Yeah, plus or minus 2. And then plus or minus 4. Is that okay, everybody? You always start with plus or minus 1. And you always end with plus or minus that number. Okay? So these are factors of the constant term. These are factors of the leading coefficients. And then the rational zero theorem tells us that the possible roots are the numbers in step 1. Okay, the number in step 1 divided by the number in step 2. Okay, and then you look at each number. Plus or minus 1 over plus or minus 1 is plus or minus 1. Do you agree? Yes. And then plus or minus 3 over plus or minus 1 is plus or minus 3, right? And then plus or minus 1 over plus or minus 2 is plus or minus 1/2. Is that okay, everybody? Yes. And then plus or minus 3 over plus or minus 2 is, yeah, plus or minus 3/2. Okay. And lastly, plus or minus 1 over plus or minus 4 is plus or minus 1/4. Right, everybody? And then plus or minus 3 over plus or minus 4 is plus or minus 3/4. So those are all the possible rational roots. Is that okay, everybody? Okay. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 numbers here, right? So we have 12 numbers. Look at the degree. What's the degree here? 5. So this polynomial can have at most 5 roots. Do you agree? So we have 12 numbers here. So rational zeros have theorem tells us that if we have rational roots, then the rational roots must be on the list. But not all the numbers on the list are the roots of this polynomial. Okay? Think about it. We only have 5 roots, but there are 12 numbers. Of course, some numbers are not roots. Is that okay, everybody? All right. Okay, so now let's continue. Okay, so next problem, we want to factor completely and find all zeros of this polynomial. Okay, so we start with, so we always start with the constants. That's the numerator of your possibilities. Okay, so we look at factors of the 6. What are factors of 6? And plus or minus 2, and plus or minus 3, and plus or minus 6, right? Okay, and then how about factors of the leading entry? What's the leading entry? 2. So they are plus or minus 1, plus or minus 2, right? Okay, what are the possible roots? So we use the numbers in step 1 divided by the numbers in step 2. Plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 2 over plus or minus 1? 2. And do you see when you use all these numbers divided by plus or minus 1, it's just all these numbers? So let's write these down. So we have plus or minus 2, plus or minus 3, plus or minus 6. Okay, and then plus or minus 1 divided by plus or minus 2 is 1/2. Yeah, plus or minus 1/2. And how about 2 over 2? 1. Do we need to put plus or minus 1 here again? No, we already have it in the list, right? Next one. 3/2, right? So plus or minus 3/2. How about next one? 6 over 2 is 3. We already have that number on the list. Is that okay, everybody? So these are all the possible roots. So far, so good, everybody? Awesome. Let's continue. Okay. So after we find the possible roots, then we need to use the rational zero theorem to find a root. Okay? So let's try. So we remember a number is a root. If we put the number into the polynomial, we should get what? 0. Exactly. So we try. Okay, so step 4. Try those numbers. So try x equals 1. Alright, so try x equals to 1. Then we have p of 1 equals what? So we plug in x is 1. You know 1, the whatever power is 1? So 2 plus 1 minus 13. And then plus 6. Is this 0? No, it's not 0. By the way, you do not need to plug in your calculator and tell me what the number is. You just need to show me it's not 0. Okay, everybody? Bless you. Okay, and then we continue. -1. P of -1. What's -1 cubed? -1. So we have -2. -1 square, 1. -1 times -13, positive 13, right? And then plus 6. Is this equal to 0? No, right? Because we have more positive numbers than the negative numbers. So it can be 0. Right, everybody? Yeah, take notes, take notes. And then we continue. The next number on the list is 2. So P of 2 equals, okay. So yeah, for those of you who did not take notes, okay, right now, at home you can watch the recording. And when you watch the recording, you can control the speed. So you can pause at every step to think through the math, and you can take notes at that time. Yeah. So up to you. But I want to make sure, yes, you learn it and understand every step. If you have questions, feel free to ask me. Okay. All right. So 2 times, what's 2 cubed? 8. And then plus 2 squared. 4, right? And minus 13 times 2 plus 6. Is that okay, everybody? We're plugging 2 for x here. What's 2 times 8? 16 plus 4. What is? Yeah, and then plus 6. Oh, what happened? Yeah, equal to 0. How nice. So x equals to 2 is a root. Okay? If x equals to 2 is a root, what is the corresponding factor? X plus 2? X minus 2. Yes. So x minus 2 is a factor. All right. Okay. So you look at this problem. This problem, what's the degree? Degree is 3, right? So we start with degree 3 polynomial, and then we use the rational zero theorem. So RZT stands for rational zero theorem to find one root. Okay? Because then after you find one root, you know your P of x is gonna be that factor and times some other stuff. But because this guy is degree 3, then that some other stuff is a quadratic factor. Is that okay, everybody? For quadratic factor, we can find it by quadratic formula. Okay? That's why you're not going to plug in all these numbers. No. You just need to find one. Is that clear, everybody? Yeah, because it might happen that some factor, if it's a repeated factor, or maybe you have irrational numbers as roots, or complex number as roots, then even though you plug in all those numbers, you couldn't find the other roots. So don't waste the time to plug in all the numbers. You just need to find one root. Is that clear, everybody? Yes. So after we find one root, then use long division or synthetic division. Okay, synthetic division. In this case, x minus 2 is a good number, right? Okay, so we can use synthetic division is easier. Do you agree, everybody? Yeah, so synthetic division. The root is 2. Okay, what are the coefficients of the polynomial? 2, 1, negative 13, 6. Okay, move it down. 2. 2 times 2, 4. Add them. 5. 5 times 2, 10. Add them. Negative 3. Multiply by 2. Negative 6. Add them. 0. Oh, do you see the remainder is 0? Yes? That's always the case because x minus 2 is a factor. Alright, everybody? The remainder is 0. Okay. Then what is the quotient? Negative 3 and then 5x and then 2 x squared. Exactly. So put this right here. So P of x is x minus 2 times this 2x squared plus 5x minus 3. Okay, everybody? Okay. So for this guy, you either like factor it or use quadratic formula to solve it. Let's try to factor it. If we can, then we use the quadratic formula. Can we factor it? We do negative what? 3 and positive 1? Do you see that, everybody? Factor 2x squared, the factors of 2x and x. Negative 3, they are 1, negative 3, or negative 1 and 3. But then if you put it here, see, do I miss the sign? Yeah, I should put the sign. See, sometimes I make mistake too. And then we have 6x and minus x. That's why we get 5x. So this is the factorization. Awesome. So let's write down the roots. Okay, so this root is 2. How about this root? 1/2. And this root? Negative 3. How about the multiplicity? Remember, multiplicity is the exponent of the corresponding factor, which is, what's the exponent? 1. Oh, actually, do you see all the multiplicity are 1? Yes? Okay. So this is how you answer the problem. You want to find all the zeros. And you also need to find the multiplicity. Okay? If some factors are repeated, then you have to write down what the multiplicity for that is. So far, so good, everybody? Okay. So if we have degree 3 polynomial, use rational zero theorem to find one root. And then use long division to find the remaining quadratic factor. Once you get that, you can either factor it or use the quadratic formula to find all roots. Okay? That is for degree 3. What if you have degree 4? Okay, what if you have degree 4? Any guess? So, okay, so if we have degree 4, we use rational zero theorem to find 2 roots. Okay? Then you can use the simple division or long division to find the remaining quadratic factor. Because quadratic factor, you can use the quadratic formula. Okay, everybody? Yes. Okay, so that is example 4. Okay. Let's continue. Okay. So, let's see. This one, this one just leave it as an exercise. Okay, let's do example 5. Okay. All right. So, step 1, what's step 1? Yeah, find the factors of, what's the constant term? 10. What are factors of 10? Plus or minus 1, plus or minus 2, 5, 10. Awesome. And then factors of, what's the leading coefficient? 1. Oh, then we just get plus or minus 1, right? Awesome. So how about the possible roots? Yes. Good. Right, because it's only divided by 1, then we just those numbers. So far, so good, everybody? Yes? Okay, now we plug in the numbers. So let's try, what's the first number? Try 1, right? Okay, what's P of 1? So we plug in x as 1. You know, 1 to the whatever power is 1. So we have 1, and then minus 5, right, everybody? And minus 5 plus 23 plus 10. Is it equal to 0? No. Right, everybody? Okay, we keep going. -1. So -1 to the 4th is what? 1, yes. -1 to the cube. -1. So negative become +5. -1 square is 1, right? So we have -5. -1 times 23, -23, plus 10. Oh, what's that? Is it equal to 0? No. Okay. Keep going. Sometimes you don't know where to stop. Okay, just keep going until you find the roots. And what's the degree? Degree 4. How many roots we need to find using the rational zero theorem? 2. Yes. So we keep going. Plug in 2. Okay, so plug in 2. What's 2 to the 4th? 16. What's 2 cube? 8. 2 square? 4. Okay, so let's see. Okay, 16. What's 5 times 8? 40. 5 times 4? 20. 2 times 23? 46. Let's see. Is it equal to 0? No. Right? Yes? So look at the negative numbers. This is -60. Positive number 14, 6 plus 60 is 62 plus 10, 72. So they're not equal to 0. So keep going. Okay, -2 to the 4th. 16. But -2 cube is -8. Do you see it then it becomes positive? And -2 square is 4. -2 times so yeah, 23 times -2 is -46. Oh, do you see 16 plus 40 minus 20 minus 46 plus 10? Do you see the negative number? -66. Look at the constant number. 10, 20, 50 plus 16, 66. Do you see 66 minus 66 is 0? Yeah, we find wrong roots. Can we stop here? No, we keep going. Okay, so we keep going. All right, so 5. 5 to the 4 and minus 5 times 5 cube minus 5 times 5 square plus 23 times 5 plus 10. Yeah, it's 5 to the 4 mistake. But do you see this is 5 to the 4? This is also 5 to the 4. Yes, 5 times 5 cube is 5 to the 4. So they cancel. Okay, and do you see 5 squared is 25? So this is minus 5 times 25. But then do you see 10 is 2 times 5? So when you combine the last two terms, it's actually 23 plus 2 and then times 5 is 25 times 5. So this is actually 0. Okay, everybody? We also get this is 0. Awesome. And then let's continue next Monday. Okay, so Friday we have exam. I will see you at 12:20. You can come here early if you have questions, and then you can put your backpack in front to get ready. Okay, so I will be here before that. Have a nice day. If you have questions, feel free to email me. Hi. You can use it as a study guide. Yeah. Hi. 1.1 through 3.4.